All right, so we're starting to talk about solving distance, rate, and time problems using linear equations. So when we're solving a distance, rate, or time problem, it's always it's important to do things like know what formulas you're going to use. Uh, so whenever you're using distance, rate, and time, I always start by writing the distance formula, just so it's there and available. So I've got distance is equal to rate times time. Now, when I look at a question like this, where we've got two trains leaving a station at the same time, I also like to draw pictures. So I'm going to write this down on another piece of paper so we have this. But solving distance, rate, and time problems. And usually what I find is going to be the easiest thing for us to do is to draw a picture and then label it. So I've got two trains leaving one station. One is heading east, the other is heading west. Eastbound is traveling at 95 miles per hour. The westbound is traveling at 85 miles per hour. And we have a total distance of 252 miles. So now I'm going to switch over to this. And our question on this is which of my two trains, or how long does it take to travel 252 miles, to have 252 miles between our two trains? Well, the thing is, we've got everything we need right here, because we have our speeds, we have the distance, but remember, like I said, rate times time is equal to that distance. So I've got the rates times the time. So if I were to add together the distance of my westbound train plus the distance of my eastbound train, it should equal my total distance. This is why I like to draw a picture to help us figure this out. So I've got 85t. This is our westbound train. Our eastbound train is 95 times t. That's our distance of our eastbound train. And our total distance is going to be 252 miles at a certain time. Well, let's add these two things together and find out what we've got. Adding these things together, I've got, looks like I'm going to have 180t is equal to our 252. And now I'm going to divide both sides by 180. And when I do that, I should come up with a nice answer. So I've got 252 divided by 180. That actually comes out to be, t is equal to 1.4. Now remember, whenever you're doing this, you need to have units. So it takes 1.4 hours. So I'm starting to look at another example here. And here we've got Chris driving to the mountains last weekend. There was heavy traffic on the way there. So the time to get there was 7 hours. So it took 7 hours. When he drove home, there was no traffic, and the trip only took 5 hours. His average rate was 18 miles per hour faster on the trip home. So what I'm going to do is if I say r is equal to like my rate on the way there, I'll have another rate is going to be r plus 18. It's going to be faster. And once again, I like to draw a picture. So I'm going to move over here. So On the way to the mountains, it was 7 hours, and it was 1 speed. And on the way back, it was 5 hours, and he was 18 miles per hour faster. Well, the funny thing is, the distance isn't going to change between his home and the mountains. At least we hope not. So these two distances are going to be the same. And I believe our question was asking, how far away is he from the mountains? So let's figure that out. These two distances are going to be the same, which means r times r7. I'm going to rewrite that as 7r because we're probably a little bit more used to seeing our variable second. I'm going to put that 5 up front as well. 5 times that r plus 18. And these two distances are the same. I got my rate times time. Well, let's figure out what this is going to look like. We've got 5r, or oops, sorry, I'm getting really excited with my 5. 7r is equal to 5r plus 5 times 18 is going to be 90. And then I'm going to subtract 5r from both sides. So I've got 2r is equal to 90. So when I divide both sides by 2, I've got r is equal to 45. So that means that I think his name was Chris. He was driving 45 miles per hour on his way there. He was driving 45 miles per hour for 7 hours. Chris is also a saint. But let's also figure out what our distance is. And I'm going to choose the easier of these two calculations. If I wanted to, I could use this one. But here I'm just going to say, well, I've got this, actually I'll do this, 45 times 7 is equal to our distance. 45 times 7, that's going to be, and that's going to end up being 315 is equal to our d. And because we had this in miles per hour, this is going to be 315 miles. That's a long way to go to the mountains. Okay,